Today we're talking about creating ball joints in Nomad Sculpt. Ball joints are essential from everything from creating flexies to designing technical parts. But how do you do it in Nomad Sculpt? I'm Brian DeLuca from Make or Build It, and this is the Art of Articulation series. Today we're talking all about creating ball joints, and if you haven't seen the other episodes, we talk about all different types of joints, from chain joints to hinge joints. So if you're interested in creating flexies, this is probably the one video series you're going to want to subscribe to. But how do you create a ball joint in Nomad Sculpt? Why would you use Nomad Sculpt to create a ball joint versus something else such as Blender? Especially when you're creating flexies, Nomad Sculpt provides an organic and intuitive interface for shaping and modeling objects, making it perfect for custom design flexies that need things like ball joints. It is especially useful for freeform sculpting and for projects that require fine adjustments to achieve perfect fit between interlocking parts. Now, whether you're working with an action figure, a prosthetic limb, or a mechanical design, Nomad Sculpt offers tools to create functioning joints. Now we're going to look at how to create a ball joint step by step. So open up Nomad Sculpt. We're going to leave our default sphere where it is. Next, we're going to add a cylinder. Now we're just going to size the cylinder so it fits inside the center of the ball. And this is going to become, like say for instance, the limb. This is going to be what's protruding from the joint itself. This could be anything from your neck or one of your limbs on your 3D model. Now what we're going to do is we're going to open them back up, select both of them, and do a voxel remesh and make these one object. Now we're just going to rename this, for instance, limb. Now these are one piece and we could rotate it or move it as need be. Now we're just going to go and add a cube, and this cube is what our joint's going to sit in. This could be anything. For instance, this could be the shoulder of your 3D model, or it could be the head of your 3D model, for instance. But here, let's just make believe it's our shoulder joint. So what we're going to do is we're going to position that where there's a little bit of the spear sticking out of the actual cube itself. We're going to straighten the limb we made because I shifted it a little to the side real quick. And now that it's in place, what we're going to do, we're going to rename the cube itself to shoulder, let's say. Now we're going to take the shoulder and we're going to go to blending, and we're going to make it opaque so we can make sure that the spear is inside of the cube itself. Now we're going to go back and we're going to change the opacity back to 100%, because sometimes when you leave it not at 100%, it acts a little odd. Now we're going to go here and we're going to duplicate our limb. That way we have an exact copy sitting in the same place. Now we're going to go back and make sure our ball joint is sitting inside of the shoulder. Now we're going to hide one of the limbs, and we're going to take our second limb and move it out. Now, as you can see here, you have the ghosted part of your first limb. And what we're going to do is we're going to do a voxel remesh to remove the first limb we added. Now, as you can see, we have our hollow hole, and that's going to be the socket for the ball joint. Now what we're going to do is we're going to shrink down the ball joint slightly, or our limb, and we're just going to slide it into place. Now we're going to make sure there's gapping around the spear itself. So we're going to go and we're going to make it opaque so we can actually see if there is space around it. And it looks like there is. Now we're going to export our file as an STL and throw it in our slicer. Okay, once it's in our slicer, we're going to slice it, and already right off the bat, I sort of see a small problem. Do you see that blue dot at the top? It looks like the top of the spear may be hitting the top of the cube. So I'm just going to bring it down. I can see where the spear goes. So I don't really like the way that looks. So what I'm going to do is I'm going to go in and I'm going to adjust this joint. And what I'm going to do is then bring it right back into the slicer itself. So I recreated the joint, and let's just take a look at the slice itself. Now we want to make sure there's gapping all around the spear. And we see that. We see there's space all around the spear, which will give us enough wiggle room for that joint to move. Now, we know we're going to need some supports here. We're going to use the tree supports, and we're just going to reslice real quick. We're also going to go look and see how those tree supports are around that ball and socket joint to make sure they're not going to be an issue and we'll be able to remove them easily. Okay, looks good. So let's slice this one and get it printing. So it's really easy to remove the tree supports from this ball and socket joint, and you see the joint rotates freely. Some tips for success in creating a ball joint include test prints. If you're new to designing joints, consider printing test models in smaller sizes before committing to a final print. This will help you adjust the tolerance without wasting material. Material choices. Stiffer materials like PLA or PETG will create much more durable joints. Post-processing. After printing, light sanding can help smooth and improve the joint's movement. Creating a ball and socket joint in Nomad Sculpt allows for incredible customization. Whether you're designing an articulating figure, mechanical part, or anything in between, the key to success is the details. Ensuring for a snug fit, planning for tolerance, and choosing the right materials. With a little practice, you'll be able to design a 3D printing joint that will both be functional and durable. We're going to make more videos exploring other types of joints, and if you haven't watched our video on chain link joints, I highly recommend you do that because it is one of the most used joints in designing 3D models, especially flexible ones. So make sure to follow Maker Builder for other 3D printing, DIY, and maker projects, and remember, keep on making.